Hello, you might be wondering why I've got a pair of scissors and a piece of card. Well, I want to set you a challenge. This it's got 5 sides, so it's a pentagon. What's the smallest number of triangles I could cut it up into? Well, let's have a look. I'm going to cut along here. Oh yeah, that'd be a nice idea. I'll cut along there. It makes a nice trapezium there. And oh look, I've got a nice bit of a square. Let's cut that across there. Oh, but I hear you saying you're not doing this very efficiently. No, I'm not, am I? Oh dear. I'm trying to cut this into as few triangles as possible. And if I cut like this, so here are the pieces I cut it into. 1, 2, 3, 4, 5. But originally it was a pentagon. And I could have cut a pentagon into fewer pieces than that, couldn't I? Surely. What would I need to do? Well, I've got here a number of polygons that I can test my theory on. If I'm going to cut these as small as possible into the fewest number of triangles as possible, then I need to cut them from their corners, from one corner to another. Now this helps me to define a formula, because if I look at this pentagon, you can see I've coloured in the 5 angles, and I want to know what's the sum of those 5 angles in a pentagon. This trick of cutting it into as fewer triangles as possible is helpful. So let's see how we can cut this one. So I've got my pentagon. I'm going to cut across here. 1, and then I'm going to cut straight across. So I have cut my pentagon into just 3 triangles. Now if you look carefully at those 3 triangles, you'll notice that all the corners of those 3 triangles are coloured green, and that's because all of the angles in the pentagon have been shared out to make the shape, to make the 3 triangles. So with a pentagon, 5 sides, I could only make 3 triangles. So let's see how I get on with a quadrilateral. 1, 2, 3, 4 corners, and I'm going to cut straight across this quadrilateral, and there you can see straight away 2 triangles, and you can also see that all the angles have been shared out between the 2 triangles. So that was my quadrilateral. I've got here a hexagon. It's got 1, 2, 3, 4, 5, 6 corners. I wonder how many triangles I need for this one. Well, I'm going to play the same game, go from corner to corner. So if I cut across there, that's 1. I'm going to cut across there, 2, and now I'm going to cut across here. And once again, if you look at these triangles, you'll notice that all the corners are completely filled with the corners of the original hexagon. I'm starting to get a bit of a pattern going here. So let's just see what happens with this shape, which has got 7 corners. So it's a heptagon. If I cut this one, so I'm going to cut right across there, and that will give me well, I'm going to have 2 smaller triangles there, so those 2, and now I'm going to cut across there, and finally I'm going to cut straight down there. Now I have, with my heptagon, I would have had 5 triangles. Actually, I've still got 5 triangles. So I've got my heptagon and I've cut it into 5 triangles, and if you look carefully you will see that again all of the angles have been shared out so that they are angles in the triangle. So if we know the number of triangles, and we also know the number of degrees if you share out the angles in a triangle, we can do some simple maths and work out the formula for the sum of the angles inside the original heptagon. Well, perhaps you didn't believe me when I told you that the shapes have been cut into the triangles and all the angles have been carefully distributed. So if you look here, we have on our quadrilateral, it's got all 4 of its angles, and there they are split into the 2 triangles. Here on the pentagon, 5 corners, all carefully split between the 3 triangles. Here we have the hexagon with 1, 2, 3, 4, 5, 6 corners and carefully split. We have got 4 triangles. Over here we've got the heptagon, and with its 7 sides we have created 5 triangles, and there we have all of the angles cut up into pieces. So this one angle here actually got shared into 5 of the triangles. Lastly, we had the stellated octagon with its 8 corners. Some of them are reflex angles. If you look, we have cut it very fairly into 6 triangles. So to summarise, 4 sides, quadrilateral, we can make 2 triangles. So the number of sides here, all of these numbers, are 2 fewer than all of those numbers. So if I had here 7 sides, 7 angles can be shared between 5 triangles. So the total number of degrees in this heptagon is the same as 5 times 180. So if I had n sides on my polygon, I would have n angles. I need to subtract 2 from that, so it gives me n minus 2 triangles, and I need to multiply by 180 because there are 180 degrees in a triangle, giving me the formula for an n-sided polygon, which is n minus 2 times 180.